I'm Jason. Let's see. This is in my 5th year at Sencha. This is my 4th SenchaCon. Anyway, I'm going to be talking about Electron today and what we've been doing with it. So before I get started, can I get a show of hands? Is anybody here currently using Electron that isn't a Sencha employee? 1, 2. All right, cool. So I know this is advanced techniques for building XJS applications, but with Electron. But one person's advanced is another person's trivial. So I'm going to start from the beginning, kind of explain what Electron is and why you might want to use it. So, put simply, Electron is a way to use web applications to build native desktop apps. And you may not have noticed this, and I think we talked about it a little bit at the keynote this morning, but Sencha's been using Electron for about 2 years now to build a number of our what you think of as desktop applications. Sencha Architect, Themer, Inspector, and most recently Themer and Test Studio. So our history with building desktop applications with web technologies kind of actually slightly predates my tenure at Sencha with Sencha Architect. And back then, 5-6 years ago, there wasn't a way to use web tech to build desktop applications except for using the browser. And we actually invented our own Chrome-based hybrid solution where you could take your web stuff and you back it inside of a native container and away you went. And we maintained that for a number of years. And then later on, this Electron thing came out, and we switched over to that earlier this year. So who's using Electron besides us? So Electron is the basis of Atom, which is a great text-based IDE, or IDE-like text editor for developers. Pretty popular. Anybody using that in the room? Yeah, I use it myself. It's great. And then Slack. So if you've been using Slack on your desktop, you're using a web app wrapped inside of a desktop package. And then even Microsoft's getting on the bandwagon with Visual Studio Code, which is a great text editor. So anybody using Visual Studio Code? Yeah. If you go download our plugin, it's amazing. Just go try it out. It's super cool. So what is Electron on the inside? Of course, it is a open source project, MIT license from our good friends at GitHub, and it is the combination of a Chrome runtime, so you can render your web application, and a Node backend, all running inside of an Electron or a native desktop application. And so it's similar if you've used Cordova to build mobile apps, it's very similar to that, only you get this rocket-fueled Node.js backend for doing all kinds of cool desktop stuff. So some of the reasons why you might want to do this is inside of your organization, it might be difficult to control the runtime. It might be easier for you to install a desktop application than it is for you to get your users off of Internet Explorer or whatever junky version you might happen to be needing to support. So that's one reason. That way you have one modern Chrome to develop on, Chrome-based runtime to run on, and you don't have to worry about anything else. You might need desktop integration features. So you might need privileged access to the file system, more so than what you can get with just a file picker. You might need to be able to run native code. And Node is great for running native code on their particular target environments. And so if you have native code you need to run, or any other kind of like desktop integration, menus, files, tray, the tray on Windows, the taskbar or the menu bar on Mac OS. Pretty much anything you would want to do on a desktop application you can do with Electron. And as I mentioned before, if you've got a lot of heavy work to do that you don't want to bog down your web process with, you can offload it to Node. And so you can pretty much build any kind of complex business tasks or background processing. Anything you want to do, you can do with Node. And of course, it's running locally, so you don't have to worry about network connectivity or offline access or any of that kind of stuff. Platform support. So it pretty much runs everywhere you want to be. So that a Visa thing? Anyway, or MasterCard. Windows, 62-bit, 32-bit or 64-bit, Mac OS, and a whole bunch of different Linux architectures. And also, the way that Electron is packaged, it makes it pretty easy to build applications on any of those environments. So you don't have to necessarily have to have a Mac to build a Mac binary for Electron, because the binaries come prepackaged for you. So that makes things a little bit easier for you. So how do you use it? Or actually, before I get into all the nitpicky details, I want to do the demo first. So show you what we're talking about here. Unmirror. I need to unmirror my display. And so as I think we mentioned in the keynote this morning, we're open sourcing some of our scripts that we use to build and deploy and manage our Electron apps, along with some other widgets and doodads that I'll get to here in a minute. But I've got my project all set up and done all the npm install and all the other boring stuff. And I've got a command running as well, building the app. And so I can just do a simple npm command, and up fires my desktop application. So so here it is. I've got it running in dev mode, so I've got the dev tools, and don't really have any menus, and it's a pretty minimalistic Chrome. But then of course I've got this nice familiar XJS application. So if you've seen if you've done a use command to build a default application, that's pretty much what you get. And so I've got a desktop application running my web app, and I've got access to all my tools. And so this works, this is Chrome Dev Tools on the right here. Can everybody see that okay in the back? I can maybe blow that up a little bit, or maybe too much. But I can do all the debugging that I would normally be able to do, see what happens as I click around. So I can get into my app and debug it just like I would in the desktop. But because this is Electron, I can do a few nifty things that I couldn't normally do. So I've got this a couple of buttons here, and I can dynamically generate menu items. I don't know if you can see all the way at the very top of the screen there. But I was able to, by clicking those buttons, create these menu items. And of course, those menu items could be used to do anything you want. Let's see, what else do I have in this demo? I've got in the an advanced file picker that's using the Electron API for accessing files, as opposed to the browser API that you're familiar with. It gives you a few more access controls that you don't normally have. Let's see yes. So this one lets me pick a photo, and using a node module, it goes and pulls out the color palette out of that image I just selected. And so that's something that would be pretty difficult to do from a browser without involving some server uploading files and whatnot. And so that's I think that's the extent of the demo. Let me take a look at the source code. So actually, I'm going to go back to the slides. Let's go back to the slides. Talk about it a little bit more, how it works, and I can jump to the code in just a second. Oh, I did it again. 1 second. Seems to not like it when I switch between mirroring and not mirroring. Hopefully it'll come right. There we go. Nope. While we're sorting this out, any questions about what you've seen so far?
So how do you maintain your applications then if I distributed this to people in the field? They browse to it?
Yep. Yeah, that's down in the considerations and things you have to deal with at the end. Any other questions? I'll definitely get to that.
After you generate the code, can you still debug it?
Absolutely, yeah. So I can if I since it's back on that setting, I can, yeah. So this is the Chrome, as I was saying, this is the Chrome Dev Tools on here. So if I want to go look at the source code, and I'm not sure if I have this one built or if this is in dev mode, but yeah. So it looks like I've got all the source code. So I can go in here and I can set breakpoints, and debug them just like I normally could in Chrome. All right.
Start off with an application with a lot of AJAX calls, and you converted it, it would still go to your server, et cetera, et cetera.
Absolutely. Yeah, so one of the things, again, finding the right balance between basic introduction to what Electron does and kind of quote-unquote advanced features. So Electron, when you can run it in two different modes. When you run it in dev mode, it can point directly at all your source files. But when you actually go to distribute your app, it packages them all up into a ASAR file, which is basically just a zip, puts it inside of the native binary and ships it away. So there's two different kind of different modes that it runs in. Let's see if I can get back to the slides successfully this time. Nope. Uh-oh. This is going to get problematic. Let's see here. Let's try it. Let's try it this way. Let's not mirror it. Ah, there we go. Okay. All right. So so that was the slide I was just going to talk about, which is so we set up a bunch of scripts in the repository. I'll give you the URL at the end. But in the we're using Electron Packager, which is a Node.js npm package. And we use a set of npm scripts to basically build and package the Electron binary and put all the pieces in the right place and turn on developer mode and all that good stuff that you'd want to do. So we have a set of like kind of pre-canned scripts to do all the various stages of building, debugging, and deploying. And then and then there's the piece about, so if you go to actually deploy your application, it zips everything up, puts it into this ASAR file, and then puts it into inside of your native container. And so the way the Electron process works is you've got your main browser process, you've got your main process which runs in Node, and then what you can call what I think Electron calls the render process, which is where your app lives. Your traditional web app lives. And so one runs in Chrome and then one runs in Node. And then the way that we've, in the example application, laid out our app is we have the app folder, which contains all your XJS views and stores and models and all the other good stuff you've got in your app, and then a main JS file which kicks everything off. And so that's the basics of kind of the way the project is organized. So the other piece is, so now I've got this Chrome process and I've got this Node process, and how do I make them talk to each other? Because they're two separate physical processes. So you have to have some method of doing some inter-process communication. And there's two kind of main ways to do this. And we use both of them at Sencha for different projects and for different reasons. The first one is your traditional client-server AJAX style that we all know and love from building web apps. So you've got your Chrome, you've got your app running in Chrome, and then you just make an XHR call to effectively a local URL. And you can do that, so if you've got an existing application that you want to kind of package up and then take your local node bits and put them all in one piece, those, of course, those AJAX calls don't have to be to the local node process. They can be to remote resources, whatever. So depending on the architecture of your application, you can either, you can just go ahead and keep using this method that you're familiar with. However, because Chrome and Node are running in the same physical container on your device, there's a few other techniques. And Electron provides, I think, two main ways of doing this. They kind of have some low-level inter-process communication calls. But there's a convenient node module called remote.require that allows you to kind of wrap up all the low-level stuff into a fairly simple, straightforward abstraction that will look really familiar if you've ever done anything with Node. And so, some of the reasons why you might want to use this is it pushes you can take all your heavy workload if you've got some, data intensive or CPU intensive work that needs to be done. You can throw that into Node and not have it block up your Chrome process. And you can think of all the different kinds of the reasons why you might want to do that. And so it's fairly simple. You can, in the top code example here, I've got the service that does some very complicated math and returns it when it's done. And then on the bottom part of the code is the piece that runs in Chrome, which is, I've got the first line is the require to pull in the package. The second line is do a remote.require, which looks a lot like a regular require of the service. And that really just gives me a local handle to the service. And whenever I call any of the functions on that object that got exported from the service, those are actually executed on the Node side. And then all the minutia of setting up and tearing down the IPC and RPC stuff gets handled under the covers. And so it does give you two outputs. It does, if the function returns anything synchronously, it will return that to you immediately when you call the function. And then it also allows you to do traditional callbacks, so for any kind of asynchronous work. And this is a method that we use fairly extensively and is a very convenient way of handing off processing work between Chrome and Node. Any questions about that before I go on to some of the other features? All right. Cool. So in the example I showed you, I had some file menus or some menus and some file browsers. And so what we've done is you can write all that code directly using Electron's APIs, but because we've got a great rich framework, we've created some of our own wrappers for it to kind of tie these elements into the XJS lifecycle and ecosystem. And so, some of the things you might want to do with the native GUI is file pickers, folder pickers, which you can't really do on a browser. Directly manipulate the tray icons, or if your operating system supports notifications, you can do native notifications. So the first example we have of a new X type we've created is the Electron file field. And so you can just use this as a drop-in replacement for file field. It uses Electron's file dialog module. And the cool thing is, of course, it supports data binding. So you can bind the inputs and the outputs to your view model, and you can tie this into your controller. So when the user picks a file, you get a callback on your controller. So we do, you could do this all manually, but we give you a nice little convenience X type just to go in and use this just like you would any other native or web-based component that we have in our framework. So here's the example of how that works. All right. So native menus. So the Electron API, of course, gives you the way to create menus directly, but we wanted to make it easier for you to tie that directly into your application if you're building an EXT application. So let's take a look at what this code looks like. So it's in the form of a mix-in, so you can mix this into your main view or your main part of your application. And you can create a config block called native menus, and of course this ties in with the view model, so you can either have inline functions or you can call out to your bound, the controller that's bound to your view, and you can dynamically populate the values of the menus based on the view model. Yeah, so they got the inline function down there. And so that's how I was able to, those buttons on that example that created the menus did exactly that. And so one of the things, so menus aren't necessarily always static. So if you have a, let's say, recent files menu item or something like that, you can actually get callbacks to generate the menu when the user clicks on it. And of course, you can iterate through, let's say, a view model data and then generate all the submenu items. In this case, file names. And it looks something like that. Right. So, of course, the menu will update. So we added some extra features in there to make sure that the menu could get updated dynamically as data changes. So something happens somewhere else in your application, you choose a new file, and now we can manually trigger a reload of the native menu. So it's all pretty simple stuff. It makes building your app quite a bit quicker and easier. And we can do this, when you get access to the repository here in a minute, you can go ahead and start playing with this stuff. So one of the other, so now we're getting into some of the more brass tacksy kind of things. So fit and finish. Now that you're not running in a browser in a sandbox environment, you have to take care to respect the conventions of your platform. Make sure you store stuff in the right place. So whether it's on Windows or Mac OS or Linux, you don't want to put things in the wrong place. So we've got some example code in there. You can, this is kind of just a quick example of using the Electron code to pick out which platform you're on and then store stuff in the right place. One of the other things you might want to do that makes your app feel more native or more app-like is tracking and controlling your browser windows. So normally in a desktop application, if you've got a whole bunch of windows open and you quit the app and you come back in, all those windows will probably show up where you left them, right? And so in a browser, you really don't have any kind, you have very limited control when you create a new window. It kind of pops up wherever, and you can sort of kind of change the size of it. But with Electron, you have complete control over the windows as you create them. So you can say where they are on the screen, whether they're minimized or maximized. You can control the Chrome, so you can make menu or make windows without the toolbars and menu bars and all that kind of stuff. And of course, you get callbacks, so you can know when they're moving, when they're resizing. And then you can store that off somewhere, and so that way you can store you can store that somewhere and then restore it later when you need to. So you have a lot more you have a lot deeper control over Windows as you're building your app. So let's see. Oops, I didn't want to go out of that. So what are some of the of course, I went all the way back. 1 second. Sorry about that. So what are some of the downsides? So when we're building web apps, the way we always have built web apps, we have tools and methodologies to put them up on a server somewhere, and our users know how to get to them because we give them a URL. But now that if we're going to use Electron, we've got a binary. So getting the binary into the hands of our users is an extra thing that we now have to worry about. So, and for most of us, we're working inside some kind of corporate environment where IT might have a great deal of say over what does and does not get installed on a machine. So, if you're thinking about using Electron, you're going to have to decide, you're going to have to understand how apps get installed into your user's environment and go pre-negotiate with whoever controls how apps get installed onto your end users' computers before you go and build the app. Some of the other big challenges, code signing. So, and this is the one that got us. It's a giant pain in the rear end. If you want to install an app either on Mac or Windows, it has to be signed by the developer that creates it. And even if you're inside of a corporate environment, it's probably going to need to be signed by some corporate enterprise distribution certificate. And so code signing is a kind of a complicated problem. It's relatively simple in execution, but if you've got your official developer private certificate, you don't want to have every developer in your organization have access to it. You don't want to put it in your source control repository so that your build server can use it. So what you end up setting up, or what we set up, was a dedicated server that just signs binaries. And so we use that as part of our development process or our distribution process. So when our CI server kicks off, creates a build, calls out to the signing server, signs the binary, and sends it back to the build server. So you're going to have to, it's an extra step, and you have to plan for it in advance, because otherwise, your users are going to get some nasty dialogue saying, what is this thing that you just downloaded off the internet? I don't think you should try to run it. It's probably not the best experience for you. And so that's code signing is definitely a challenge. And we don't have as part of the stuff we're releasing, we don't have a tried and true, repeatable process for this, but it's something we've done, and you're just going to have to go figure out what makes sense for your environment. Which kind of leads into the next step is you don't want to just give your users an executable or an APP file, or that's not a great experience either. So you're going to have to create an installer. So after you're done building and signing the app, you're going to have to pick an installer, whether you're going to use Microsoft's installer or create a DMG on a Mac, or use one of the third-party cross-platform installers like we use, called a product called We're still using BitRock, right? Yeah. Well, it's not an endorsement by any means, but it's what we're currently using. And so there's a whole bunch of different options there. You have to find one that makes sense for your environment. If you're just using Windows and you're in a corporate IT environment, maybe your IT department already has a signed headless installer distribution system that they require everyone to use. And so you have to do your homework and figure out what makes sense for you. So the next one is, how are you going to update the app once you get it to your users? Are you going to ship a new binary every single time and make them reinstall it, or run these updates? And you can do that. That's probably the easiest way. But because this is a web app, it's relatively easy to update the web bits inside of the native container. And so GitHub provides that capability. It doesn't work very well. It's not consistent across platforms, and so we ended up writing our own thing. And unfortunately, we're not releasing that thing to everyone today. But it's something we did to make sure that when either Themer or Architect needs to update, we can just update the ext app bits without having to reship a whole new binary.
But it doesn't break the code signing?
No. That's the cool part about it, because it's magic. But no, somehow it doesn't. Actually, now that you mention it, it's kind of wonder why that happens.
That's not good for code signing.
Yeah, because I think actually, now that I think about it for a second, the ASAR is stored in the document space of the app, so that might not be considered part of the binary.
Yeah, it's not part of the exe.
Yeah, so it's not part of the actual exe binary itself, so that the binary bits don't change, but it's kind of like if you had images in there, it's basically in the same place you'd put images, so I guess it's not covered by sign. I don't know. That's an operating system problem, not a... Good question. So I think I talked a lot about, so I've kind of beaten the dead horse on user adoption. The last thing you'll have to consider, and this is kind of like from the web developer standpoint, we're always putting every line of code you've ever written as a web developer is available to your end users, right? It might be compressed and mangled and not very easy to look at, but it's still, you're still shipping your source code and executing it on a browser. And nothing changes here with Electron. So if you are concerned about your security of your binary distribution, the JavaScript's still in there. It might be compressed, it might be mangled, but it's still there. And so if you care about users ripping off your code, which if you're already building web apps, it's probably something you've already thought about and considered, but you may, you don't get anything, you don't get any additional security benefits just by wrapping it in Electron. So I just wanted to call that out as something you don't get for free just by using Electron. There's still a zip, an ASAR file sitting inside of your, your app's binary that your users can go. So, and while I don't condone or endorse hacking, if you have Slack, if you guys use Slack, go look at the binary, and on Mac you can do show package contents. You dig down a few layers, and there's a Slack ASAR file that has all their source code in it. Not that it's the same source code that's on their website, but it's still there, right? And so it's just something as in our challenging IT environments that we typically find ourselves in, it's just something to think about. So, are there any questions?
So the Node.js plays the role of the web server.
Mm-hmm.
So then there's a question of cross domain, or if you want to access a distant server and that Node.js server, then there's cross domain request there that goes on. So there must be something to control that.
Yeah. So talking to the node process just counts as talking to local. So there's no cross domain there. In the case of, I think Electron is permissive by default. That's right. So it lets you, the same browser cross-domain rules that you have on a browser don't exist in Electron. So it's basically all turned off.
So with Cordova?
Yeah. Yeah. So Cordova. Yeah. So it's just like the early days. So think of it as the early days of Cordova when there wasn't a whitelist blacklist system like they have now in Cordova. But if you go back a few years in Cordova, you could request anything you wanted. Then I think was it 3 or anyway, in some version they added the whole whitelist thing, and you had to explicitly add it to your list of domains. I don't think that exists. They haven't added that to Electron yet, have they? I don't think so. Yeah.
So it's not a concern.
Yeah.
Last question is, when you said you can open up a window from the operating system,
Mm-hmm.
a separate window, it's like a separate browser at that point.
Yes.
So how do you communicate? Like, is there any communication between that new window and the base window now?
Yeah, so it's not. We didn't have any ext bits that we added to that to make it any easier. But Electron has an API for doing cross-window communication.
So that window would be like a whole separate world with its own whole separate loading of whatever.
Yes. Yeah, because it's just another Chrome process. But the advantage is you're loading everything off local disk, so it all happens pretty much instantaneously.
I'm curious about what your experience has been with, for example, Windows. Let's pick One OS.
Mm-hmm.
The memory management, not the memory. How much RAM does the process use? I mean, does it seem heavy? And second question, follow up is, if you look at Task Manager, is it just one process running, or is there multiple processes? Do you see more than one process running?
Yeah, I think on Windows, that's a good question. I'm spend way too much time on Mac. On the Windows side, do you happen to know off the top of your head? Or Don, are you in the back of the room somewhere? One of our Windows-focused developers. Yeah, in terms of memory usage, I don't have any hard numbers, but I would imagine that the Chrome and so you're running Chrome, same memory footprint, and then of course you've got Node running, which can be very light but can get big if you use a lot of Node modules. So.
With our products, most of them are built with that architecture, so you're not getting more than 3 gig max anyway. It's just never been a concern, at least with what we built.
Because then you're at the mercy of the user's client, who knows what they're running.
Right. Yeah, so I mean, I wouldn't think of Electron as being a low memory it's probably not a very memory light product in general, just because of the technologies it's using. So I wouldn't try this on a highly memory constrained environment. But for our use cases, we're talking about developers. It's usually we're usually okay.
So what's the story about using like desktop-like development toolkit like SDKs and stuff like that? Can you just pull up your SDK in there and play with Node.js and then use an SDK from some hardware vendor or something like that?
So so you're talking about native Node modules, or Node does support. Electron does support native Node modules. So if you're familiar with native Node modules, you can get Node modules that have binary code.
Put binary in there on
Yes.
your own and attach it to Node. Basically.
Yeah. So your mileage will probably vary, just like any native Node module. But and I think there's probably a growing library of those available now. There was in the black. Or no, sorry. Yeah, it looks like you have a black shirt on from back here. Sorry.
In the case where you want to maintain both the desktop version and the web version, so just Slack,
Mm-hmm.
can you keep a single code base and configuration path in one or the other environment?
Yeah, I think. So the question is, can you have one code base if I've got a web app and a desktop app? I think the general answer is yes. If you've built your app well to run in a browser and to run in Electron, depending on how much stuff you do in Node, it will either be easy or hard. So if you're doing a lot of if you're doing a lot of so like the RPC method I was talking about, you probably wouldn't want to use that if you were trying to build that sort of model. You'd want to build more of a traditional client-server app. And a lot of people, like the first time they build an Electron app, will just take their web app, package it up, and ship it. Just like a lot of people that used Cordova really early on, like me, you just take your web app and you wrap it in Cordova and be on your way. So I think the question would be, is the app that you're building on the Node side, does it have enough extra, are there features that you could just turn off when you're running on the web that you can live without, right? If you're doing a lot of high bandwidth RPC calls or stuff that works really well on a local network between two processes that won't scale when you're talking about tens of milliseconds or hundreds of milliseconds of latency, you might have to consider that. But I think the general answer would be yes. You could easily maintain one code base.
Would that be like Cordova, where you have it in your app JSON, like on the build section?
Yeah. Oh yeah. Oh, you're talking about so unlike So this is a separate set of npm scripts. It's not directly integrated with command just yet. So the version we're putting out today is really, you take command, you build your app, and then you use these set of npms, or basically shell scripts inside of npm to do all the extra post processing. Sorry. I'm sorry. You've had your. I didn't see you. Go ahead.
Any possibility to run C# code inside?
Yeah. If you can create there's two options there, two general options there. Create an npm module that has native code that happens to be C#. The other option is you can build extensions directly into Electron. So I think we've done that in a few cases for some stuff that we do where we actually build direct extensions. Of course, you'd be limiting yourself to platforms that C# runs on. So, but sorry, yes.
Maybe answer this at the very beginning of this, very beginning. JavaScript.
Mm-hmm.
Is that that's not translated into C#?
No.
I mean, there's no performance improvement by running it in the Electron browser?
So if you apples to apples, let's say you take so the way Electron works is that they have a recent version of Chrome, and so if you have the same version of Chrome, it'll most likely your app will be approximately the same performance, and then Node will be the same. So you're just running JavaScript, highly performant, best browser engine there is, JavaScript, but it's still JavaScript in the hoodie, or you're right there. Sorry, say that a little bit louder.
If it's possible to create apps for Windows Store?
Yes, so we don't submit any apps to the Windows Store, but I believe there's a guide on the Electron site itself for how for making sure that you jump through all the right hoops for both Windows and for the Apple App Store. So if you want to distribute apps that way, that's definitely an option. All right, any other questions?
Did you already share the link in the?
I'm saving the best for last.
Oh, okay. What kind of problems did you run into with trying to push updates to an app? Was it just because of the OS differences?
Dan, you want to? You got any particular? I think the mechanisms. It's just that Electron doesn't provide you with very rich mechanisms for doing app updates yet. I think there was a couple of very early on they had something that was Squirrel or what was it? Yeah, is it still Squirrel? Yeah, so that and it only worked on Mac and so it's just not very sophisticated. No Linux support. So I mean that's why we had to roll our own kind of update. I mean it's really all it is. There's a few pieces to updating app. You got to check to see if there's a new version. That really wasn't there, or at least not in any kind of sophisticated way. And once you do have the new version, you got to know how to download it. You got to put the download in the right place, and you got to refresh the app. So those are kind of the crude steps that you run into. And so you basically just have to go build those. So you got to have a server somewhere that you can check for updates, and in our case, we have to check licenses and a few other things. So. Any other questions? All right. I know it's getting late. This is the last talk, and I think I'm the only thing between you and pool party beer. So I guess any other questions, we can chat outside or at the pool with beers in hand or whatever beverage of choice. But here's the demo, or here's the URL for our Electron examples. So it's Sencha/Electron-demo, and I'll let everyone take photos of that. And that is, I think, everything I've got. Thank you.